Good morning, Professor and friends. My name is CharuBhattarai and I live in Irving, Texas with my family. And this is my final project presentation on CNN. So, first of all, let me describe what is CNN. CNN, it stands for Convolutional Neural Network, which is a deep learning network which is used in image processing, image recognition, and image classification. It especially used to process pixel data. CNN follow hierarchical network model which works on building a network and give a fully connected layer. CNN take the raw pixel data or image and train the model, then transform the model for great features. So CNN neural network, it is basically used for image processing. The image can be both 2D and 3D, and CNN transform the input volume into output volume. So CNN is a type of artificial neural network used in image recognition and processing that is specifically designed to process pixel data. A neural network is a system of hardware or software pattern after the operation of neuron in the human brain. So the CNN is basically used to build, train, and test the dataset having images. Image can be both 2D and 3D images. So after that, we can compare the performance of the neural network and we can improve the performance. There are so many ways we can do it. So this is all about defining the CNN, convolutional neural network. In second slide, I'll show you how to design the CNN and train the CNN model. So we can't design CNN model, but we can pick the similar CNN model and change this according to your tasks. You don't haven't trained it from scratch. No need to train it from the scratch. We can pick the similar CNN model and change this according to the tasks. You take your model that have trained for a large data set and find a way to adapt problem. This is called transfer learning. If you are working on novel problem, then take the idea from the successful model and design a new model working to your tasks. So these are the different steps to how to design CNN model. Now, how to train the CNN model. So there are different steps to train the CNN model as well. The first step is create your own image data set, assign path and create categories, resize your image. Training is an array that will contain image pixel and index at image categories list. Shuffle your data set, provide label and features, convert label to categorical data, split your data set according to use, and then the last step is to compile and train the CNN model. These are the different steps to train the CNN model and to design the CNN model. We need to follow these steps for the accurate neural network performance. So without following these steps, the neural network performance won't be accurate, won't work as expected. So going forward, we need to implement the same changes while training the CNN model. Now this is the architecture of CNN neural network. So this is the image, input is the image, and the input is processed and the output is generated. So there are different steps, like a convolutional, subsampling, full connection, Gaussian connection, different steps. So it goes in by steps, and create a complete clear architecture of CNN. So CNN, the image recognition is the input, and the output is shown clearly in this diagram. It has a different size and different numbers. So we can increase and decrease the size according to the requirement. So what are the steps for building, train, and test the convolutional neural network? So convolution, fully connected, pooling, rectification layer, dropout layer. So I have built, train, and test the model using the CIFAR10 dataset. Dataset has been loaded directly from TensorFlow API. Also, optimizer is needed. Trainer is created to train CNN model. After that, minimize the optimizer. We are ready to train and test the deep learning method. The number of steps is 5,000 with batch size of 50 images, and the total size is 50,000. We have 50 images and 50 label in each batch. The trainer name is CNN trainer, input X and output is Y. Then for training, we test the model every 100 times, every 100 steps. So we have altogether 5,000 steps. Then for testing, we test the model every 100 times, every 100 steps. Here the value matches, that means it has high level of accuracy. In our model, the accuracy is 99%, which matches the values. So accuracy, if we if we train and test the model in a proper way with a proper value and using proper data set, then the accuracy percentage will obviously be high. So we should never miss any value and never use any incorrect value. So different steps, convolution, fully connected, pooling, rectification layer, dropout layer, all those are different steps to build and train the convolutional neural network. So the first step is set up a convolution layer and perform convolutional computation. So these are the command to run to set up a convolution layer and perform convolutional computation. So the shape value will be same with the MNIST dataset, and set up ReLU layer and perform convolutional computation dot product plus bias. So this works for the first one works only for dot product, but the second one we will work for dot product and the bias. So create final fully connected layer, compute x dot w plus v and produce final output. So this is the command to create a fully connected layer. After that, set the steps equals to 50,000. Then using this command, we can find the accuracy percentage. So in this screenshot, it is showing the accuracy is 68%, but we can improve this accuracy and we can compare its performance with multiple data set. So I have compared it using CIFAR 10 and CIFAR 10 and MNIST dataset. So in this the PowerPoint slide which I am currently presenting, that is for the CIFAR dataset. So here the accuracy is coming as 68%. Compare the performance, neural network performance compare the convolutional neural network performance. Neural network performance has more accuracy rate using MNIST dataset in comparison to CIFAR dataset as shown in the below screenshot. Using MNIST dataset, accuracy we found is 99%, whereas using CIFAR dataset is 68%. Dataset accuracy is much less in CIFAR 10 using CIFAR 10 dataset, but it is using MNIST, the accuracy is 99%, which is a very good rate. So dataset like CIFAR 10, which is a dataset containing natural image, and MNIST, which consists of handwritten digits, were used to perform the experiment. Here steps is updated to 1500 to train the CNN model. I have noticed that while running the steps, previously percentage jumps from smaller to higher till 98% of the end of the training steps. So how can we improve convolutional neural network performance? I have figured out the different process to improve it. So the first step is, once we follow all these steps, our network performance will be better. So one could use image data augmentation to further improve the performance of the convolutional neural network. When the access to training data set is limited. Image augmentation refer to generation of new training image using existing training image by so a sample code to rotate an image by 90-degree counterclockwise is mentioned below. So these are the code which rotate an image in counterclockwise. XYZ equals to image.open img1 in the first image, and XYZ rotated color image rotate 90%. So this is how we improve the convolutional neural network performance. By using image augmentation technique, the existing data sample generation and increase by a factor of approximately 4 times. By using these parameters, new images are generated, which are helpful for improving the convolutional neural network. Image augmentation refers to generation of new training image using existing training image by enjoying by applying specific change to the image. Generally use image augmentation parameter include rotation, zoom, share, etc. So in overall conclusion, this project is all about build, train, and test a convolutional neural network and to improve the performance of the network. Convolutional neural network is a deep learning. So this project, it is all about build, train, and test the convolutional neural network and to improve the performance of the model. So convolutional neural network is a deep learning algorithm which is used in image processing, image recognition, and image classification. In part 3, I have a build, train, and test the CNN. In part 4, compare the convolutional neural network performance with MNIST and CFAR dataset. And in page 5, so in overall conclusion, I found below advantage of convolutional neural network over the normal dense network in processing images. Convolutional neural network can be feature learning. Feature learning or representational neural learning is a set of techniques that allow a system to automatically discover the representational needed for feature detection. Normal neural network can't do this. So there are several advantages of our CNN over the normal dense network. Thank you. The remaining will be covered in next slide.